All right, let's dive into this fascinating world of natural language processing. Um, Specifically for you guys, grad students and researchers working in health and science, we've got some really interesting material to go through today. From a grad level NLP course, so, think like syllabus stuff, overviews of different modules, and even some background readings to really get you thinking.
Yeah, the goal is to give you a solid foundation in NLP, particularly in those cutting edge areas, generative AI and large language models.
Exactly. Those are the real game changers these days.
For sure. And what's really cool is seeing how you can actually apply these technologies in your own academic work and research. I mean, NLP is already revolutionizing healthcare and scientific research as we speak.
I know, it's mind-blowing. It's like we're
Yeah.
finally able to tap into this massive amount of language data that we've always had. All those research papers, medical records, clinical trial notes. I mean, it would be impossible to process all that manually.
Right, exactly. NLP gives us the tools to make sense of it all.
It's like having a superpower for dealing with information overload. You know what I mean?
Absolutely.
But before we get too far ahead of ourselves, let's take a step back and make sure we're all on the same page with the basics. And, it might sound kind of funny, but one of the best ways to understand how NLP works is to think about how toddlers learn language.
That's actually a really good point. They start with simple babbling, then single words, and eventually they're able to, string those words together into
Right,
sentences.
just like little language geniuses.
NLP follows a similar path. It starts with basic tasks like identifying parts of speech and then moves on to more complex challenges like understanding the sentiment behind a paragraph.
Or even like you were saying earlier, generating text that's almost indistinguishable from something a human would write.
Exactly.
Mm.
Exactly.
So it's almost like we're teaching machines to learn language the same way we do. And speaking of learning, the course materials highlight some key moments in NLP history that really set the stage for where we are today. Like, personally, I was really fascinated by the rise of voice assistants, like Siri and Alexa.
Oh, yeah, for sure.
It felt like science fiction was suddenly becoming a reality.
It was a huge turning point. I mean, all of a sudden we were actually interacting with machines using natural language.
Right, and it was surprisingly effective.
Yeah. And then there's machine translation, which has gone from, a cool novelty to a tool we rely on every day for global communication. Think about how Google Translate has completely changed how we access information and connect with people from different cultures.
It's incredible how far these technologies have come in such a short time. But honestly, what really blew my mind was the emergence of the transformer architecture around 2018.
Oh, yeah, that was a big one.
The course materials describe it as a total game changer, but I'd love to hear you explain, like in your own words, why it was such a big deal.
Sure. So before transformers came along, most NLP models really struggled with long-range dependencies in language. Basically, understanding how words relate to each other, even when they're far apart in a sentence or a paragraph.
So like making those connections even when the words are all jumbled up.
Exactly. And the transformer architecture solved this problem by introducing this mechanism called self-attention. And basically what this does is it allows models to process information in parallel and consider the context of every word in relation to all the others.
So it's like the model can see the whole picture, the big picture,
Yeah.
instead of getting lost in the individual words.
Exactly. And this breakthrough led to the development of these really powerful pre-trained language models like BERT, which stands for, get this, bidirectional encoder representations from transformers.
Wiki.
Right. BERT was trained on a massive amount of text data, and it could understand the nuances of language in a way that previous models just couldn't.
It's really amazing how these advancements have paved the way for even more sophisticated NLP applications, like the course mentions text summarization. That could be a game changer for researchers trying to get through mountains of scientific papers.
Imagine being able to instantly get the key takeaways from a dense research article without having to read the whole thing. I mean, that's the power of NLP.
That's amazing.
And then there's sentiment analysis, which can be used for all sorts of things, like gauging public opinion on a topic or tracking the emotional tone of customer reviews.
Or even like identifying potential mental health issues based on what people are posting on social media.
Exactly, it's incredible.
It really is incredible how NLP is being used to solve real-world problems in so many different fields. But before we get too carried away, let's go back to those core NLP concepts, the ones that form the foundation for all of these amazing applications. I know your syllabus goes into some of those essential terms like tokenization, lemmatization, and stemming. I mean, they almost sound like something out of a Harry Potter spell book.
Huh. They do have a kind of magical quality to them. But really, they're just fancy ways of describing the basic building blocks of NLP. So, like, tokenization is basically the process of breaking down text into individual units, like words or sentences.
Okay, so kind of like dissecting the language.
Yeah, you could say that. And then lemmatization and stemming are techniques that are used to reduce words to their base form so that we can group similar words together and analyze them more effectively.
So it's like we're creating a language for machines to understand.
Exactly. It's all about making the text as clean and structured as possible so that our NLP models can work their magic.
I love that. Work their magic.
Yeah.
And the course also mentions things like part-of-speech tagging, named entity recognition, and stop word removal. I have a feeling these are all connected somehow.
You're right, they all work together. So part of speech tagging is basically identifying the grammatical role of each word in a sentence. Like, is it a noun, a verb, an adjective, and so on.
Okay, makes sense.
Then named entity recognition takes this a step further by identifying specific entities like people, places, organizations.
I see, I see.
And then stop word removal involves filtering out common words like the a and, which don't carry much meaning and can clutter up our analysis.
So it's like we're refining the ingredients for a recipe.
Exactly. You've got to chop, dice, measure everything carefully before you can start cooking. And speaking of delicious recipes, the next big ingredient in our NLP feast is large language models, or LLMs.
LLMs, those are the big players in NLP, right? The ones that are making headlines with their ability to generate human quality text and even hold conversations.
That's them, yep. They're a type of artificial intelligence that's been trained on massive data sets of text and code, so they're able to understand and generate human language with remarkable fluency and accuracy.
It's pretty amazing.
It is. They're the driving force behind many of the NLP applications we've been talking about, and they're only getting more powerful as time goes on.
I can't wait to learn more about them, especially how they actually work and what makes them so unique. But I have a feeling that's a whole other chapter in our NLP journey.
You're absolutely right. LLMs are a fascinating and complex topic, but we've got to save something for next time, right?
Right. Keep them wanting more. Okay, so before we jump into those LLMs, I'm kind of curious about something. You mentioned earlier that NLP models, even the really advanced ones, they all start with those basic building blocks like tokenization and part of speech tagging. It seems like there's this whole hierarchy of concepts going on here.
Yeah, you're absolutely right. It's helpful to think of NLP as a pyramid, with those fundamental concepts forming the base and the more complex applications like text summarization and sentiment analysis at the top. Each layer builds on the one below it, allowing us to tackle increasingly difficult language tasks.
So if we really want to reach the summit of this NLP pyramid and harness the power of these technologies, we need to understand how all the pieces fit together, right?
Exactly. It's like learning a new language. You start with the alphabet, then you move on to grammar, and eventually you're able to read, write, even have conversations.
Yeah, I like that analogy.
NLP is the same way. By mastering the foundational concepts, you'll be able to understand how the more advanced applications work, and you might even be able to start building your own NLP models.
That's pretty cool. But for now, I'm ready to dive into those large language models, those LLMs you mentioned before. The course materials describe them as a game changer for NLP, but I'm still a little fuzzy on what exactly they are and how they work.
Okay, well, imagine having access to like a massive library of human knowledge, all encoded in a way that a machine can understand and use. That's essentially what an LLM is. It's a type of artificial intelligence that's been trained on like a huge amount of text data, allowing it to learn the patterns of human language.
So it's like this superpowered language learner that can absorb information from millions of books and articles and websites.
That's a great way to put it. And because LLMs have been exposed to so much data, they're able to perform a wide range of language tasks. And they do it with remarkable accuracy. I mean, they can translate languages, write different kinds of creative content, answer your questions in an informative way. They can even generate dialogue that's almost indistinguishable from a human.
It sounds like science fiction. But if LLMs are so powerful, why haven't they replaced humans in all language-related tasks?
Well, that's a good question. While LLMs have made incredible progress, they still have their limitations. For example, they can sometimes struggle with tasks that require common sense reasoning or understanding the nuances of human emotions. And they can also be susceptible to bias, especially if the data they were trained on reflects existing societal biases.
Right, so it's important to remember that LLMs are tools. And like any tool, they can be used for good or bad.
Exactly. We need to be thoughtful about how we develop and deploy these technologies to ensure that they're being used ethically and responsibly.
Absolutely. Now, I'm curious about the different types of LLMs that are out there. I know the course materials mention some pretty interesting names like BERT, GPT-3, and T5. Are these all different flavors of LLMs, each with its own unique strengths and weaknesses?
You got it. The world of LLMs is incredibly diverse, and new models are being developed all the time. Each model has its own architecture, training data, and specialized capabilities, making it suitable for different types of tasks.
It's like a whole ecosystem of LLMs, each with its own unique role to play. So let's start with BERT. The course materials describe it as a foundational LLM that's been incredibly influential in the field. What makes BERT so special?
Okay, so BERT stands for Bidirectional Encoder Representations from Transformers, and it was a big deal when it was released back in 2018 by Google AI. One of BERT's key innovations was its ability to process text bidirectionally, meaning it considers the context of both the words that come before and after a given word.
So it's like BERT can read between the lines, understand the subtle nuances of language in a way that previous models couldn't.
Exactly. This bidirectional approach allows BERT to capture more information about the relationships between words and understand the meaning of a sentence more accurately. And because BERT was pre-trained on this massive data set of text, it came with a deep understanding of language that could be easily adapted to a wide range of tasks.
That's fascinating. It sounds like BERT laid the groundwork for a lot of the LLMs that came after it. Speaking of which, the course also mentions GPT-3, which seems to be getting a lot of buzz lately. What's the story behind GPT-3 and how does it differ from BERT?
Okay, so GPT-3 stands for Generative Pre-trained Transformer 3, and it was developed by OpenAI. It was released in 2012. And it made a lot of headlines because of its ability to generate incredibly realistic and coherent text, to the point where it was sometimes hard to tell if it was written by a human or not.
I remember seeing some examples of GPT-3's writing, and I was blown away by how creative and fluent it was. It felt like a major leap forward in AI.
It was definitely a big step. Unlike BERT, which focuses on understanding and analyzing text, GPT-3 is primarily a generative model. It's trained to predict the next word in a sequence, and this allows it to generate original text, translate languages, write different kinds of creative content, and even answer your questions thoroughly.
So if BERT is like the master of understanding language,
Hmm.
GPT-3 is the storyteller.
That's a great way to put it. But while GPT-3 is a powerful tool, it's important to remember that it's still a machine learning model, and its output can sometimes be a little unpredictable or even nonsensical. It's also really important to be aware of the ethical implications of using such a powerful generative model, especially when it comes to potential misuse or spreading misinformation.
That's a really good point. It's easy to get excited about these new technologies, but we always have to remember the potential risks too. Now, the course materials also mention P5, which seems like a bit of a hybrid between BERT and GPT-3. Is that a fair assessment?
You're on the right track. T5, which stands for Text-to-Text Transfer Transformer, was developed by Google AI. It came out in 2019. And it's designed to be a versatile LLM that can handle a wide range of tasks, both analytical and generative.
So it's like T5 combines the best of both worlds.
Exactly. It uses a unified text-to-text framework where all tasks are formulated as converting an input text sequence into an output text sequence. This allows T5 to be trained on a variety of tasks at the same time, making it a very powerful multitask learner.
It sounds like T5 could be a really useful tool for researchers who need an LLM that can adapt to different language tasks. Now, we've talked a lot about these specific LLM models, but I'm curious about the bigger picture.
Mhm.
Are there any overarching trends or themes that are shaping the development and evolution of LLMs?
Yeah, that's a great question. One of the most noticeable trends in LLM research is the push toward larger and more powerful models. We've seen this with GPT-3 and the models that came after it. Increasing the size and complexity of these models can lead to big improvements in performance.
So it's a bit of an arms race to see who can build the biggest and most powerful LLM.
Uh-huh. Yeah, there's definitely an element of that. But it's not just about size. Researchers are also exploring new architectures and training techniques to make LLMs more efficient, robust, and adaptable.
It sounds like the field of LLMs is constantly evolving, which is exciting, but also kind of makes it hard to keep up. But before we get too carried away with all the possibilities, I want to circle back to something you mentioned earlier, the importance of using LLMs ethically and responsibly. The course materials go into some of the potential risks associated with LLMs. I'd like to get your thoughts on how we can mitigate these risks and make sure these technologies are used for good.
You're right. The ethical considerations surrounding LLMs are crucial, and it's important that we're having these conversations as researchers and developers. One of the biggest concerns is the potential for bias in LLM output. Because these models are trained on huge data sets of text, they can accidentally learn and perpetuate biases that exist in the data. And this could have serious consequences, especially in fields like healthcare, hiring, and criminal justice.
So it's like the saying garbage in, garbage out. If we feed LLMs biased data, we're going to get biased results.
Exactly. That's why it's so important to be careful about the data that's used to train these models and to develop techniques for identifying and reducing bias in the output.
Another thing that worries me is the potential for misuse of LLMs, especially for things like creating fake news or hate speech. I've seen some pretty disturbing examples of AI-generated content that's super realistic, even though it's totally made up.
I hear you. That's a valid concern. As these models become more powerful and easier to access, it's crucial that we develop safeguards against misuse. This could include things like watermarking AI-generated content, developing ways to detect fake content, and educating the public about the potential risks of LLMs.
It seems like we've got a lot of work to do to ensure that LLMs are used responsibly and ethically. But I'm also really optimistic about their potential to do good in the world. I'm especially interested in how they can be applied in research, so I'm eager to learn more about the practical tools and techniques that are available.
Well, that's a great transition to the next part of our deep dive, where we'll be exploring the exciting world of prompt engineering. Prompt engineering is a key technique for controlling and optimizing LLM output, and it's essential for anyone who wants to use LLMs effectively in their research or other applications.
That sounds incredibly useful. I'm ready to learn the secrets of talking to these AI wizards and getting them to work their magic.
Let's dive in.
Okay, I'm ready to unlock the secrets of prompt engineering. Make those LLMs really sing. But before we get too deep into it, can you kind of give me a high-level view of what this whole prompt engineering thing is all about?
All right, so think of prompt engineering like the art of writing really good instructions for LLMs. It's how we communicate with these AI systems to get the answers we want. Like a conductor leading an orchestra. A prompt engineer guides the LLM to produce something meaningful and relevant.
So it's not just about asking a question, it's about asking the right question in the right way.
Exactly. You've got to understand the LLM's strength and its weaknesses and frame your prompts in a way that plays to those strengths. A good prompt can make a huge difference.
That makes sense. I could definitely see how this would be important for researchers who are using LLMs, to analyze complex data or generate hypotheses. But it also sounds a little intimidating. Are there any, rules of thumb for effective prompt engineering?
Yeah, definitely. There are best practices. The course materials go over a few key considerations, and I think it's worth breaking them down a bit.
Perfect. Let's do it.
Okay, so the first thing is clarity. Your prompts need to be clear, concise, and easy to understand. Avoid using jargon or terms the LLM might not get. Remember, you're talking to an AI, not a human expert.
So keep it simple, like writing for a general audience.
Exactly. The next principle is specificity. Be super specific about what you want the LLM to do. Like, don't just ask for a summary of a research paper. Tell the LLM what parts of the paper you want it to focus on, how long you want the summary to be, what kind of style you're going for.
So it's more like giving it a blueprint than a rough sketch.
I like that. The more specific you are, the better the LLM will understand and deliver what you're looking for.
Makes sense. What else should we be thinking about?
Well, context is super important. You need to give the LLM enough background information to really understand the task. For example, if you're asking it to analyze a scientific paper, give it a little summary of the research question, the methods, the key findings.
So don't just throw it in the deep end without any context.
Exactly. You want to set it up for success by providing all the information it needs.
Okay, clarity, specificity, context. Got it. Anything else?
One more that's really crucial, especially for research, is bias sensitivity. As we talked about earlier, LLMs can sometimes pick up biases from the data they were trained on. So when you're writing prompts, think about that. Think about ways to minimize bias in the results.
That's a really important point. We don't want our research to be affected by hidden biases.
No.
How can we actually address that through prompt engineering?
Well, one way is to explicitly tell the LLM to be objective, to avoid using biased language. You can also provide it with a balanced set of examples, representing different viewpoints on the topic.
So it's like we're training the LLM to be aware of its own biases, right?
Yeah.
And to aim for neutrality.
Exactly. By being mindful of bias and trying to reduce it in our prompts, we can make our research more objective and trustworthy.
That's really helpful. I'm feeling a lot more confident about writing good prompts for my own research now. But I'm also curious about the different kinds of prompts that are out there. Are there certain categories or styles that are particularly useful for specific tasks?
Oh, absolutely. The course materials actually outline a few different types of prompts, each with its own strengths and uses. One category is what we call informational prompts. These are used to get factual information from the LLM, things like definitions, dates, statistics,
So it's like using the LLM as a superpowered search engine.
kinda. Informational prompts are great for getting quick answers to specific questions or gathering some background information. Then we've got instructional prompts. These are used to tell the LLM to do a specific task, like summarizing a text, translating a document, or writing something creative, like a poem.
So it's like giving it a set of instructions, a recipe to follow.
Right. Instructional prompts are how we tap into the LLM's ability to create something new.
What other types are there?
Well, there are comparative prompts, which we use to compare and contrast different ideas or concepts. For example, you could ask the LLM to compare two research methods or analyze how two historical events are similar and different.
That would be super helpful for research. It's
Yeah.
like having an AI assistant that can help you analyze information from all these different sources.
Exactly. And then there are creative prompts, which are all about stimulating the LLM's imagination. You can ask it to write a story, compose music, even come up with new scientific hypotheses.
Wow, the possibilities are endless.
They really are. Creative prompts let you tap into the LLM's potential to generate new ideas and expressions. It's pretty amazing.
This whole concept of prompt engineering is really mind-blowing. It's like learning how to speak AI. And as we've been discussing, it's such an important skill for researchers and really anyone who wants to use LLMs effectively.
Couldn't agree more. Prompt engineering is essential in this age of AI, and it's only going to become more important as these technologies keep evolving.
This whole deep dive has been so insightful. I feel like I have a much better grasp of NLP, LLMs, and prompt engineering now. I'm excited to start using these tools and techniques in my own work.
That's great to hear. Remember, this field is constantly changing, so keep learning and exploring. There are always new discoveries being made. And as we wrap up, I want to leave you with this thought. The future of NLP is really bright, and the potential for these technologies to change how we live, work, and interact with the world is just incredible.
I'm definitely excited to be a part of it. Thanks so much for guiding me through this deep dive. It's been an amazing learning experience.
It's been my pleasure. Keep exploring, keep learning, and keep pushing the boundaries of what's possible with NLP.